this webinar. Hello, everyone. I'm going to share a quick presentation on our high current products. So what's coming, why is it coming, and why modules keep evolving in this way. You should see my presentation now. Okay, as we saw before with the inverters, quickly touched on, but as that the current keeps going up, we increase current on modules. And I'll just give you a big quick background on this. We're moving from different cell sizes or wafer sizes. Reason for that is you can see there at the bottom of my slide, we're going sort of higher and higher in efficiencies, and going to bigger cells drives efficiency. On the other hand, it also brings up the current, but it has many advantages. So that's why you see this development's driving, and many of the things are driven by utility scale requirements for large volume. And that's why you see more and more scale of economics as well in this, and wafer sizes just will continue going up. You know, the old 156 round about there, gone. 166, it's nearing the end of its lifetime, and we're really moving into 182 millimeter wafers and 210. 210 really ideal already for utility scale. This is what you find everywhere now in projects. 182 is a really nice sweet spot for residential, and we will see the 182 formats for some years to come. Has pushed modules a little bit bigger. We're all working hard to match them to the inverters, match them to the handling capabilities as well, and to install availability on roofs. But you can see the common theme is here, efficiency going up. You know, only over a few years, we keep pushing up more and more in sort of the mid-20s soon. How do we do it? I just touched on it briefly, basically using utility scale development. And the biggest step change really we saw in the last 5 years when the market has moved from the standard back contact solar cells to the PERC solar cells, which in essence gives you a bifacial solar cell. And this is now every utility project out there is bifacial. For rooftops, it doesn't really make sense to put a bifacial module on. However, what you will find, even packaging this PERC bifacial cell technology in your backsheet modules, you have a bifacial effect. You still gain from it. You utilize light that would go otherwise through the cell. You absorb this in the back, you utilize light that goes between the cell gaps, bounces off the back sheet. And this is how we drive up the efficiency. We cut the cells in half. Everyone's used to this now. It just gives you much better low light performance, gives you lower operating temperatures and hotspot protection as well. So these are really the key drivers to go to larger cells all the time. There we go, the 6R. That's going to be the success of the 370 watt, which most people are used to. So 370, 390 watts. This is now going to be succeeded by the 415. And then from 415, we start stepping up 420, 425. But for the Australian market, 415 is the sweet spot, because we look at how many modules do you need for a typical 6.6 install. So typically you will use 18 panels or more. Now we're really dropping it down to 16. And this is where we see the major benefits for the installers: less time, less equipment, and for transport. We package now over 30 modules, 35 modules in the pallets. That means you load a pallet, you're good for 2 jobs out there a day. What's really in it? A lot of detail. Again, it's this power, 415. We can go a bit higher, but the Australian market will see predominantly the 415 round about there, because that's what most people want for their system divisions. The efficiency, really, it is a big achievement to go sort of 21, 21.5 and towards 22% efficiency. It means you just ever have less room needed on the roof and less heat. Less heat, especially in an Australian context, means you operate more efficiently. So your yield over the year is much better. And with the right inverter coupled, you utilize and you see definitely much more power coming out of your system and money back in your customer's pocket. Just a few features from our end. All our residential modules have 25-year product warranty. It's a major stepping stone. Since we introduced this, customers have just had positive feedback. It just gives this extra confidence when they put it on their systems. We also have as a standard salt mist protection. Our major cities are all near the water, and this is just the standard, and customers again appreciate that. Now, talk a lot about good modules, and we have good modules, some of the best, but we have noticed some customers, good is just not good enough. They just want the very best, and they couple all the components to have a premium market offering. So what have we done? I lent here sort of examples from the EVs. If you look at VW, they have a trusted product, they have improved. So I'll compare this to the PERC. We're now sort of in electrification age, and we're really at a top notch. But some people just said they want this a little bit extra. And this is where we're now jumping, not to TopCon right now, but we're jumping one step further. We're jumping to HJT, hetero-junction. What does that give you? In essence, you get out of the same footprint, even more power. We're now pushing sort of the 22.5 and hopefully soon the 23% efficiency. When you consider that the theoretical efficiency with technology we're using these days is about 28%, we're coming really close in a real practical world to those efficiency limits. You can push 440 watts. In the beginning, we're probably going to test the market with 430 and then see how it all works with the inverters and the system sizes. You get now a 30-year performance warranty, and even better, the degradation is so low that after 30 years, you almost have 90% of your original power still guaranteed. How does it work? Again, a technology like PERC, not new. It's been around just as long as PERC, but it took a long time for commercialization. And the cell type is based again on a bigger wafer. We go to 182, and the real key of hetero-junction is you have a solar cell that's identical at the front and the back, and that really drives that efficiency, and that really drops that degradation. You see we're coming 24.5% cell efficiency, 25 is the target. Out of the laboratory, we already have 25, so there is more power to come. Why can we trust it? How can we rely on it? We do extensive testing for all our products, especially for these. And when you just compare it here, the 30-year performance in red, you have after 30 years still more power output on these products than on a standard PERC product after 25 years. That's why we specifically with this product, we tailor-made it and we brought the development forward because we know this premium market exists and people just want this kind of product, this reassurance. Reassurance, we do test to standards, but we constantly use the next standard or go above standard. Like here now, going to the IEC 63126, it just pushes those limits. We go higher on everything. That's just a list of items we test, but essence is we do not just test with the standards, they're applicable, we go above the standards. So that's my quick intro to the new product range already here in Australia and coming.